Welcome back. So nice to see you again. In this video, we are continuing on our topical solution series from the paper of IGCSE and Maths. The topic we are looking at is series or progressions. In this video, we're going to look at one of these topic questions from the paper is taken from May-June 2020. Paper 2, Variant 2. Here we go. Let's take a look at the question. It's spread over to 2 pages. Part A. The first 5 terms of a sequence are given below. Well, it was given there 4, minus 2, 1, minus or negative 0.5, and then positive 0.25. We know that with the patterns of the flow, the sequence, it doesn't look very possible. In fact, it is quite impossible to be an arithmetic progression. Why do I say so? Yes, I've heard your reply almost before I even complete my questions. Congratulations. Yes, because if it is an arithmetic sequence, it can either go gradually ascending with the additions of the same amount of what we call common difference in a positive value, or it can be descending in a consistent deduction of one common difference, which is a negative value. Okay, but for this series, we notice that it is from positive 4, goes down to negative 2, and then go up to positive 1, and so on. Then you know that you can confidently rule out arithmetic progression. Well, the next possible that you have in mind will be geometric progression. There you go. What we're going to do is let's go and test it out, and even more advantageous is you can find for yourself its common ratio. So let's hit 2 birds with 1 stone with this simple test or workings. Here I put down the common ratio is we take the term, divide its previous term. Therefore, minus 2 divide 4, and then you can take 1, divide minus 2, you can take negative 0.5, divide 1, you can even take 0.25, divide negative 0.5, and as I have listed all the way here, and you notice that each of them shares the same ratio, which is negative 1/2, or equivalent to negative 0.5. Yes, we have managed to achieve 2 purposes with 1 effort. The first one, we confirm this is a geometric progression without doubt. Secondly, you have got for yourself its common ratio as negative 0.5. And therefore, at the same time, you also know the first term of this progression is 4. With those information, let's proceed to what the question asks of us to do. Part 1, find the 20th term of the sequence. Well, n equals to 20. Exactly. I can hear that from you. Yep. So what we're going to do is we can take the n term formula from the formula sheet, or you may even quote it out by heart. Just put it down. N term for geometric sequence is a multiply r to the power of n minus 1. Substituting the A equals to 4, substituting R equals negative 0.5 accordingly, you have got for yourself a nicely concise anthem for this series. And now, what you want to do is just take another simple step for finding the 20th term. Yes, n equals to 20. Take the n equals to 20, substitute n equals to 20. There you go, substitute. And with the help from the calculator, yep, I'm sure you got this display on the calculator screen. Yep, the mark scheme accepts your answer in this manner. You can even pack it up in this manner, and you can even pack it up as that manner. So with that, you have successfully get for yourself full 2 marks for part 1. Now let's move on to part 2, all the way aiming at the 2 full marks. Read the question, explain why the sum to infinity exists for this sequence. And, well, that's another part of the question. Beware of missing out any of them, yeah? And find the value of the sum. Okay, let's launch without hesitation. First, explain the why sum to infinity exists. Well, we know, okay, it was even hinted to us at the formula sheet that the sum to infinity existed only with the condition the common ratio must lie lesser than 1 and bigger than negative 1. So that's what we're going to put in. To answer the first question, its common ratio is negative 0.5, which is between, it is bigger than negative 1, but smaller than positive 1, or you can even put it as the absolute notation, where the absolute of R must be lesser than 1. There you go. You have done the first part of the question. Let's move on to the second part. Find the value of the sum. Okay, they have showed us sum to infinity. Go and get that formula, sum to infinity from the equation. Well, A equals to 1 minus R. You have known previously A is 4, R is negative 0.5. Without doubt, just substitute the A accordingly and the R accordingly. Then full marks coming your way as you sum up the infinity at 8/3. Congratulations, you've done well so far. Let's flip the page to the second part. Okay, part B. The 10th term of an arithmetic progression is 15 times the second term. Full stop. Wow, quite a lengthy sentence. And as I highlighted there in 3 different colors, well, the first part, the highlighted in blue, will know that in math notation, n equals to 10, and then you know that the 10th term n relates to another term, which is the second term. So n equals to 2 or u2, their relations is the u10 is 15 times the u2. Well, that is the statement that we wanted to pay attention at, and we're going to make full use of it to our full marks. Let's progress step by step. Translating the first part, being the 10th term, you take from the formula sheet the u of n, the nth term, substitute them with the n equals to 10, you get a plus 10 minus 1, multiply the common difference, and you get for yourself a plus 9d. Then you proceed to the sentence on the phrase on the second term. Work out the second term in terms of the a and d. So a plus 2 minus 1. Why is that 2? Yes, because for second, therefore n equals to 2. Then you get for yourself, second term is defined as a plus d. You've got the 10th term, you've got the second term. Now you go back to abide by the sentence given relationship between the two terms. Here we go. They stipulated for us the 10th term equals 15 times of the second term. You're in good shape so far. So what you do is you take the 10th term accordingly, put down here. And then the second term, you put accordingly into here. Then you have translate the conditions or the information they give to you in one equation. So what you do is you wanted to shift everything and simplify them into one equation which you will use later. Okay, now they ask us to find the common difference. We know that they want us to find a D. Okay, so with that statement, you know that there's a D. And as we have mentioned previously and repeatedly telling us, for this topic, we quite often and almost all the time will encounter solving of simultaneous equation. Then it looks like we are going to face the same situation real soon. Now, what we're going to do, let's progress to translate the second statement. The one I highlighted in orange, it put up there the sum of the first 6 terms. N equals to 6, or S of 6 is 87. So what you do is you take the formula from the formula sheet and put down here, and then you're going to substitute accordingly. Here we go. Half, yes, and n, you got it. N equals to 6, 2a plus, what's n here? Yep, you got it. 6 minus 1, multiply d, and equate 87. How do we know 87? Yes, it is given to us. So what are you going to do now? Just go on, simplify, and make them into another equation. So what I've done here is I just simplify the 6 divide 2 into 3 and expand the bracket into 6a plus 15d equals to 87. Okay, so now due to restriction, limited space, so I did not recopy the 2 equations. I hope you can see it here. So this is the first equation, and then this is the second equation. So now we're going to proceed to solve simultaneous equation. So what I have suggested to do here is I am going to multiply the coefficient of A to make them equal. Well, you may choose whichever method of solving simultaneous equations as you like, as long as you're confident, as long as you're accurate. That's the matter. In fact, from here onward, you may not even have to be same as what I am doing here. Okay, yep. So what we do now is after I multiply the equation 1, I multiply this equation with 6 through, and I got it as 84a plus 36d equals to 0. I name them equation 3. And for the equation 2, in order to make the coefficient of a same, so what I do is I multiply with 14 through, and therefore we get 84a plus 210d equals 1218. And I called it equation 4. Now, what I plan to do now is eliminate a. Therefore, I just take equation 3 minus equation 4, and you get for us minus 174d equals minus 1218 with a division of minus negative 174 both sides. We comfortably and accurately obtain the value of D, and we successfully answered part 1 of here of B. Now let's move on to B2. For this progression, the n term is 6,990. Find the value of n. Okay, we want to find value of n, and given to us the n term, and we know that we're going to use the n term formula. And as we want to use the n term formula, we know we have got the value of D, and you surely know that we haven't got the A. Therefore, let us follow through from part 1 and to find A. Therefore, let us substitute the D equals to 7 into any of the equation that we have there. Well, I just randomly take equation 1. Therefore, I just subbed D equals to 7 over here. Therefore, I get 14a plus 6 times 7 equals to 0. With a few steps of solving for A, we got the A as negative 3. By now, I know, it's so excited, right? With just a few tiny little steps to our completion, and make it even more awesome. You're having full marks on your way. Okay, what are you going to have? Yes, you got the A, negative 3. You got the D, which is 7. And you got the n term, which is 6,990. That was given to you. Sub them into the formula that was so kindly printed at the formula sheet. Then, by doing that, you just take a few steps of simplifying, solving this linear equation for n. Yep, so minus 3, expand the bracket into 7n, expand this into minus 7, and you combine minus 3 minus 7, you got for yourself minus 10, and now you plus 10 onto both sides, and that leaves you 7n equals 7,000. By dividing 7 both sides, yes, you got for yourself n equals 1,000, and that is full mark for you. Yeah, we have come to the end of this question, and congratulations, you've gone through yet another awesome journey. Thank you for your time. Yep, 4 marks, and for 11 marks, unbelievable. All right, so I hope you continue to do more practice, and then I am sure you stand a great and awesome chance into excellently well scored in your exam. Okay, so I'm looking forward to see you in the next solution series, and I might be also preparing another on this topic, or yet another topics on the IGCSE and Maths. Well, just subscribe the channel, just like the video, and then keep posted. Then if you have any requests on any other topics or questions, do just post it to me or let me know, and I will look into that. Okay, all I can surely say is that you're going to have happy learning and just going to have an awesome, great time learning and awesomely successful. Okay, so I'm looking forward to see you again in the next video. Keep yourself healthy, strong, and happy learning all the time. Bye-bye. See you.